Alright, so I could explain to you what I'm gonna do, but I think it would be better to just show you. So, I'm gonna take this gumball, and let's roll. And that's a success for feeding the kitty.
For those of you left unaware of what that was a Rube Goldberg machine, which is essentially just a mechanism that uses several small moving parts as part of an overly complicated chain reaction to accomplish a very simple task. It's essentially just doing something the most overly complicated way you can possibly imagine. But it's fun, because there's a bunch of interworking parts and it's fun to see how they interact with each other to accomplish the end goal. And it's got a lot of science in it too, if you take the time to look for it. But in order to find some of that science, we're gonna need to do some math. And math is kind of boring, so while I go over all that stuff, you guys can watch the video of my cat eating all the food I spilled on the floor with my experiment. Well, first off, it's fairly obvious that the main component here is conservation of momentum. We start with our gumball weighing at 9.3 grams, rolling from a 45-degree incline towards the first domino. The gumball loses a lot of its gravity given speed, as it is an imperfect shape and loses speed due to friction, not to mention all the times it bounced into stuff. Nevertheless, I've determined that it reached the first domino with an average velocity of 0.34 meters per second. We can use that to determine that the momentum of the gumball at the moment of the impact was 3.2725 gram meters per second, and we can use that to find the information for the domino it hit. I had to run through a test a few more times, but I found that the velocity of the gumball after it hits the domino is about negative 0.13 meters per second, meaning it went just a little bit backwards. And we can use that to find the velocity of the domino after getting struck would be about 0.88 meters per second, seemingly enough to cause it to fall over and strike the next domino in sequence. And the numbers for the next dominoes will all be the same because they have the same mass and final velocity of 0 after hitting the next one in line, meaning that when the metal ball is struck, it is hit by a domino with a momentum of 4.36 gram meters per second, and the ball, having a mass of 15 grams, is sent moving with a velocity of 0.29 meters per second, and it begins to pick up speed because my countertop is slightly off kilter in the direction the ball was rolling. Then the ball rolls right off the table and into a cup that was roughly 1/3 of a meter below. The ball's acceleration due to gravity here would be 1.35 meters per second squared, providing it with enough force on impact to cause the cardboard base to move and release hold on the model car sitting above, knocking over the bag and ending the chain. Now, if anyone actually wanted to see the numbers, I did put them here. They're all here now. But it's not the numbers that make this whole thing cool. It's the understanding of concept itself. It's just awesome how one small movement goes through a progressive chain, all without needing any more input other than what was offered in the original movement. Which is precisely why Rube Goldbergs are amazing, because it takes conservation of momentum to hilarious extremes. Now, mine wasn't extravagant given my limited resources, but others have gone nuts with this stuff. There's a band by the name of OK Go that on more than one occasion has made a Rube Goldberg machine that also doubled as the instrument in their song. Of course, I didn't do anything that cool, but it does show how amazing all this stuff is. Because it's all just physics. That's what makes it cool.